Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com in the topic of kinematics. The title is Position Time Graphs, Conceptual Analysis. I actually want to start by looking at the formula so we can begin to understand how where the concepts come from. Remember, we looked at this equation in our matching pairs video. I will link that here. But we see that the speed or velocity, and I am going to kind of merge the two in our discussion here. Speed is distance divided by time. Velocity is displacement divided by time, and really it's a change in time. I don't want to get into all that too much right here. We do want to talk about the difference that speed has no direction. It's a scalar. Velocity has direction. But since it's one-dimensional motion, both are treated essentially the same. Okay? But I do want to point out distance or displacement is how much the position changes. Okay? So if we have a change in position divided by a change in time, okay, we could write it like this for the displacement formula. Okay, notice that the change in position is on the y-axis. So mathematically speaking, the change in position is our delta y. Time is on the x-axis, and so that's a change in x. And look at that, delta y over delta x, that is the slope. Okay, so we're going to see that come in conceptually in this video, more mathematically in the next video. But the slope is the velocity or the speed, which is position over time, which is delta y over delta x. So the slope is the velocity. And that's going to be a key concept as we move forward. So when we do this and we calculate the slope here, we are actually calculating the velocity. All right, so let's move on. So we're going to go through several things we see in these position time graphs, what kind of motion there is, and what that looks like on a position time graph. Let's go through them one at a time here. So first, we see that if something is stationary, it's going to be a horizontal line. Well, let's make sure we understand why that is. So we see some horizontal lines over here. D is a horizontal line. What is that telling us? It's telling us from this time to this time, as time goes on, the position has not changed. It's gone right along at the same position. Same thing with B. It's at the starting point. By the way, this calls 0 the starting point. Oh, no, I take that back. Starting point is where it starts here. Okay, I think that's what they meant. So B is at 0. Okay, so at position 0, it stays there the whole time. That is stationary. It's not moving. Anything that is not horizontal would be moving. So anything that's not horizontal would be moving. So there you go. So anytime it asks you what sections are standing still or stationary or at rest, that's another word we use for that, then you would pick the horizontal lines. All right. Oops. Clear. And on to the next one. So now, how fast is it moving? Is it moving slow or is it moving fast? Well, we know that the velocity is the slope. Okay? So V is the slope. So a big slope would be moving fast. So in this case, I think E probably has the biggest slope. A has the second biggest slope, and C has the flattest slope of the ones that are moving. Of course, 0 would be the slowest. I think they tend to ask you about the fastest. So look for the steepest one, whether the steepest one's sloping up or down. Whichever one's steepest would read the biggest on their speedometer. Okay? All right. Next, if it's moving to the right, that means it has a positive velocity. That's another way of saying it. Positive velocity, that means the slope is upwards. Okay? So A would have a positive velocity. C would have a positive velocity. E would have a negative velocity. Okay, you'll also see questions like, is it moving towards the starting point or away from the starting point? So you have to look at where it starts at time 0 So at time 0, A is moving away from the starting point, C is moving even farther away from the starting point, E is moving towards the starting point. All right, so that's how you'll do questions like that. Then finally, if you want to look at changing constant velocity versus changing velocity, since A has the same slope the entire way, C has the same slope the entire way, E has the same slope the entire way, this one has 3 sections that have constant velocity. This one, the changing velocity actually happens in an instant, which is impossible to have happen, so you'll never see that on a real graph. But for our purpose of just analyzing it, the only place the velocity is changing is at these points, where there's that we'll pretend it's a very tight curve. But over here on this graph, we see B has a constantly changing slope. It's a pretty big slope, and it gets smaller and smaller, and eventually it's at rest. D is at rest, and then it eventually gets faster and faster and faster. So B and D would be sections where it is accelerating or changing velocity. E is at constant velocity, C is at rest, and A is accelerating, or is at constant velocity as well. All right, so that is the apprentice level. You should be good to go with that. Here is, oh, nope. So here's the master level. So in that one, this one you have to do speed ranking. So just remember, this is the key, slowest and fastest. Small slope would be flattish, so the slowest would have the smallest slope. The fast ones would have the biggest slope. So you just have to look at them. Since C starts this far away and gets farther away, C is sloped bigger. A is sloped the biggest, so A would be the fastest, C would be the second fastest, and B would be the slowest in this one. So for this, because it doesn't say anything about direction, you're just talking about what's on the speedometer of the car that's driving this way. It's just the flattest one is slowest, and the steepest one is fastest. And that's the master level. Do, I think, 4 of those, and you're good to go. The wizard level gives you some dot diagrams. If you're not familiar with dot diagrams, I'm going to link you to my video, Name That Motion, if you want to learn that in more detail. I'm just going to breeze through dot diagrams and focus on the position time graphs, which is the focus of this concept builder in this video. Okay, so let's talk about what we would find out from these dot diagrams. Again, if you need more learning on that, go to the link. So first of all, these are all going to the left. Okay, that's going to be the first thing. And how can we tell that they're all going to the left? Because there's an arrow here pointing to the left on all 3 of them. Sometimes that arrow will be pointing to the right, and then you'd notice that it's going right. Then the dots, if they're close together, remember each dot gets left each 1/10 of a second. So that means as these dots are left here, 1 dot, 2 dots, 3 dots, the fact that they're close together means it's not going very far each 1/10 of a second, or each second, however you want to think of this. So this would be the slowest one because the dots are closest together. Whereas C down here, the dots are far apart. It's going the fastest. Okay, fastest. And we'll just say middle for A. Okay, so those are speeds. Once you've got the direction they're going and their speed, then we're ready to go down and look at the graphs. Well, we know that since it's moving to the left, it's going to have a negative slope. It's going to slope downwards. Since all of these are to the left, that means all of them are going to be down here in the bottom. Anything that's pointing to the right is going to have a positive slope, meaning it's going to be one of these ones. Okay, but these all 3 are down here. So we know we're going to be picking 4, 5, and 6. Well, the fastest one, we'll start with C. The fastest one, fast, means the biggest slope. 6 has the biggest slope. Okay, so C would be 6. B is the slowest. We know slowest would be the flattish one, the smallest slope. So B would be 4. And here we have A. The dots are a middle distance apart, and so that's going to be our middle speed, so that's going to be 5. Okay, and that's how you do the wizard level. Oops. There we go. And so here's the summary of all that. You can look back at this as you're doing the master level, or you'll need both of these sections for the wizard level, and you'll need the whole thing for the apprentice level. If you have any questions, please put them in the comments down below. If you enjoyed this video and it helped you learn physics, please click that like and subscribe button, and we'll see you the next time on the scientific adventures of Beardman.